Hey, what's up, Ziguanas? This is day 23 of the 30 Days of Zig Coding Challenge. Join me as I apply over 2 decades of professional programming experience and around 15 years of code teaching experience to master a new programming language. The name of the language is Zig. My name is Dusan. Welcome to Zignited. Yeah, day 23 already, which means there are only 7 days before these 30 days of coding challenge is finished. But like I mentioned a few times before, I will continue learning Zig and making videos, both live and let's say offline. So I will be active on this channel past these 30 days. I'm just going to probably change the frequency, how frequent I will go live, and I will also create more videos that are not live and that are shorter. So different nature. Those videos will be about teaching, learning, basically, so tutorials. And that's the plan. So for today, I will go through compilation part of Zig. So I will try to cover these few topics. So compile variables, compilation model, and targets for compilation. Yeah, before I continue, I would just like to say one more thing. So Robert has done an amazing job, and he improved my tic-tac-toe code. So I will see with him when he's available, so that I make some special stream about tic-tac-toe. I know I said I'm not going to make any more tic-tac-toe streams, so I plan to do the third one as the last one, but because Robert did a lot of important things there and he spent his time, so I would like to go through that code, which is for sure useful for learning purposes. So I would like to do this one more time with Robert when he will be online. So we'll see when Robert is around that I see with him that I organize this special stream for tic-tac-toe to go through his code. Okay, so now let's speak about these topics for today. So let's start from here, compile variables. Let's see what they say about, and let me zoom like this. And if I refresh, will it? Yeah, perfect. Okay. Compile variables are accessible by importing the built-in package, which the compiler makes available to every Zig source file. It contains compile time constants such as the current target, endianness, or however you accent this word, and release mode. Then they give an example how you import built-ins here, and then they create a const separator, and they say they will test if the built-in OS tag is equal to Windows. Then the separator, so this is for file paths, right? So this is going to be assigned if it's window. Separator will be backslash, right, 2 times under the quotes, like string literal, else, actually not a string, I had to be careful, so it's a single quote, so this is a character then, and this is then escape sequence, not 2 backslashes, yes. So this is going to be one single backslash character, which will be a separator if the operating system is Windows, otherwise it will be slash. Okay, so they just gave one example of what is imported with import built-in. Okay, let's see what they say here and why I don't see here the rest of the code. Okay, now it's a bit more visible. So they import, okay, this is standard Zig version. When writing code that supports multiple versions of Zig, prefer feature detection with built-in has the ECL. So probably, yeah, we went through this. This is one of the built-ins that I think I did yesterday and has field. Maybe it wasn't. So I forgot the prefix. So I definitely did one of these, but I forgot if the prefix was has or it was get or something like that. I forgot. But anyways, so they are going to explain here how they are going to use this built-in. So let's see. So they make a constant, which is public Zig version. That's the name of it that they have chosen. Then they take the standard built-in, right, a library, and then they go, or module, how they call it, semantic version inside of it, then parse, so obviously a method, and then they pass in the Zig version string. And where did they, here it is. Okay, I thought they have defined it in a different place. So this is the string that they're going to use. So the order doesn't matter. This is just, I was expecting it by intuition to be here, but the order doesn't matter. So this is the version string. They have hard-coded it here. So they will call this method parse with this version string. And this one also has at the end. So when they try to create a constant, they have a catch at the end to potentially catch something that is wrong, right? Some problem, unreachable. So then they create another Zig backend variable, which in this, not variable, sorry, constant, which they take from the built-in compiler backend stage to LLVM. I think Andrei mentioned yesterday that they have changed something in compilation, that it doesn't use LLVM. It's different now, so I'll have to recheck the video from yesterday. It was in the comments during the live chat. So let's see what next they do. Yeah, by the way, one more time, just for you guys who are maybe for the first time here. So I'm going through the documentation. I'm in the process of learning Zig. So it's not like I am Zig expert and try to teach someone else Zig. I am learning it myself. I started learning Zig 23 days ago, and I had zero experience, literally never seen a single line of Zig code 23 days ago. And I just document my learning process. And the idea is, once I finish these 30 days, that I go deeper than off stream, so that I do more work off cameras, and then I will prepare a tutorial for Zig from the beginning. So I will cover all the topics. But this is just like I'm at this stage now that I'm learning it myself. And the idea is to show to others who are learning any programming language that how you can learn, how someone who has decades of programming experience and decade and a half of code teaching experience, how someone with that kind of experience would approach learning the new language. So this is the idea. Hi Dev, how are you? Okay, so let's see what's next. They create a lot of constants. They're all public. Robert not here today. I think not, because I mentioned him a few minutes ago, because I would like to go through his code. He made an improvement for tic-tac-toe. So I would like to go to that when he's here, but I think he's not, because he hasn't responded anything in chat. Let me see what's next. So yes, they create an output mode constant, which then they take from built-in. So they're basically just showing what is inside of this built-in module, or how they call it officially. Is it a module, or how it's called? Package, yeah. So just to be precise how they name things. So the built-in package. So in this case, they take the output mode, and this is the value they assign to it. Then the link mode. So just to remind me, we are in compile variables. So this is more or less targeting compilation, right? So then the link mode, they take from the same package, link mode, and they set it to the static value. Then they have unwind tables. They set it to async. So this is, I believe, the name of the field of some structure there that's inside. Then struct, I wanted to say, not structure, sorry. Then another one is test. They set it hard-coded to false. Single-threaded also false. ABI, so they take the target from the STD, target ABI, and they select the Linux GNU, right, GNU. So then the next one, CPU, they target and they provide this tuple, which is huge. So there are so many fields. Let's just try to see the main idea. So they select the architecture. That's the first field. They say it's 64-bit. Then they select the model field and they take from the standard target x86 CPU ZN versions 4 the address of it, and they select that and assign it to the models. Then the features, which is calling, I believe, feature set looks like a method which starts here. The call itself starts here, and then it ends, I mean, the parentheses of the call end there. So all these are then parameters. But actually there is only one parameter, so it's anonymous structure, which makes it a tuple, and they take the address of it to pass it to this method. And this structure, again, I said structure, sorry, struct, contains a lot of these, so I'm not going to spend time going through all of them, but you can see the idea. So a lot of settings here. Okay, then the next thing that they do, they create another constant, they call it OS, and again it's public, so they take again anonymous struct, a tuple, and they assign it to std target OS. In this case they have several fields again. So the first one is tag, they say it's Linux, then the version range, and then they add anonymous structure here again, which I believe ends here. Wait, I have to be careful with, no, this is from the OS. This is from here. This one is closed there. And then it means this one is ending this here. Okay, so then they create a range from minimum to maximum. So they're covering the version of Linux, right? So from 6.13.2 to 6.13.2. So they are fixing it to on one specific version, to one specific version, and they then also set the glibc to this version, 2.39.0, and then the Android 14. Okay. Then, so looks like something for the mobile phone, right? So then they create another constant, target. It's a constant again, public one. And they set the std.target to, again, a tuple. So they take the CPU from the above, right? Then the operating system as well, the ABI, the object format, and those all four of them are set to, all these four fields are taking these variables respectively. And then they have another one, dynamic linker, which they hard code here. Okay. And then a bunch of other cons. So this is just like to go through them, of course, just to see how they're used in real life. So I'm not trying to completely memorize them, just to see and have an idea what's available and how things look like. So then they have a bunch of these constants, object format. They take it from the target object format, and then so the type is this one, and then they set the value to .elf. Then the mode, is of this type, and they set it to .debug. Then link libc false, so they are now setting a bunch of them to false and true. So link libc, link libcpp, so C++, and C, have error return tracing. How do you pronounce this? Volgrind support, sanitized thread, fuzz, position dependent code, position dependent executable, strip debug info, and omit frame pointer. And there is only one of these that is not Boolean, and that's this one, so code model, which is of this type, not Boolean, and they set it to .default. Okay. Build mode, yes, I will see that maybe next time. Then we move to the second topic, compilation model. Let's see what they say about here. Give me just a second to read the comments. If you don't use pub, is const private by default? Yeah, it is. So by default, everything is private. Compilation model. A Z compilation is separated into modules. Okay. Each module is a collection of Zig source files, one of which is the module's root source file. Each module can depend on any number of other modules, forming a direct graph. Dependency loops plural, between modules are allowed. Okay. So it's directed graph, but loops are allowed. In module A, if module A depends on module B, then any Zig source file in module A can import the root source file of module B using import. With the module's name, in essence, a module acts as an alias to import a Zig source file, which might exist in completely separate part of the file system. Okay. So basically there are aliases. A simple Zig program compiled with Zig build exe has two key modules, the one containing your code known as the main or root module, and the standard library. Yeah, your module depends on the standard library module under the name std, which is what allows you to write import std. Yeah, now it makes more sense. In fact, every single module in a Zig compilation, including the standard library itself, implicitly depends on the standard library module under the name std. The root module, the one provided by you in the Zig build exe example, has a special property. Like the standard library, it is implicitly made available to all modules, including itself. This time under the name root, so import root will always be equivalent to import of your main source file, often but not necessarily named main Zig. So if you do this, it will be the same like you're importing the main. It will automatically try to find it like this. Source file structs. Every Zig source file is wait, didn't I go through this already? No, I did. Yeah, I did this source file version discovery. So I probably read it in a different context, so I can go through it. Source file structs, every Zig source. Give me just a second to see what you guys write in the chat. Imports looks very similar to C++. Do Zig have classes? No classes. So they use structs. So I don't know if you're familiar with languages like Rust. So they also don't have classes. So it's not object-oriented language. You have composition instead of inheritance, because the core concepts of OOP are inheritance and some others, of course, but inheritance is the main problem when you have, depending, of course, what you want to do. Sometimes it can be useful, but the idea is that they don't have object-oriented language, so that have more, let's say, independent things that you can compose together, decentralizing. So you could say that OOP is centralized, and composition principles are making something similar but in a decentralized way. Like when you compare, for example, monolith architecture in programming and microservices. So not saying that you have to do always microservices. It would be a bad idea if you don't want to do something that is extremely large, because you will have other issues there. If you do microservices, then it becomes very hard to build and coordinate. If you have like hundreds or thousands of microservices, then you have completely different complexities. So you're decentralizing things, so you can edit the code in an independent way, which you cannot do in a monolith, but you're going to have a lot of different issues, and build times can be much longer and so on. So this is just like a different principle. It's not object-oriented programming. So like you have, for example, functional. So it's just like different idea how you can do coding. So that's why Zig doesn't have classes. It has structs. So you have structs, you have enums, you have things like structs and enums. You can have methods inside of them in a very similar way like you have in object-oriented programming. You have the concept of self, or this, however you want to call it, depending on the language. Some languages call it self, some languages call it this. So you can do very similar things like in OOP, but it's not object-oriented. You don't have classes and inheritance and things like that. Let me see, but struct don't have any functions, do they? Yes, they have. They can. So you don't have to. You can. So like in OOP, you can create a data class which doesn't contain any methods. So you can have just the class that wraps the data in a specific way. And of course, most of the classes in OOP, they will have methods, but you don't have to make classes with methods if you don't want to. So again, depending on the language, it can be a bit different how you would actually do this, but this is the general idea. And in a similar way, in Zig, you have structs which can contain methods if you want them to, and you have also enums, for example, and a few other complex data types that are basically again allowing you to have some methods if you want, or if you don't want to, you can just use them as data storage. Let me see, what else did you write? Andre, hi Andre, how are you? Let's see what Andre says. Other difference from C++ classes is lack of destructors. No class, no constructors, so no destructors. So let's see what they say about source file structs. Every source file is simply a struct. So you can imagine that the file contents are literally surrounded by struct curly braces. This means that as well as declarations, the top level of a file is permitted to contain fields. Nice, nice. So yeah, I've read something about it, but not this part, not this chapter. I did in some other part of docs. I read about files being structs. So let's see what they say. Because this file contains fields, it is a type which is intended to be instantiated, and so is named in title case. Yeah, I went through the naming conventions yesterday. So this is also interesting how they name things. Instead of snake case, by convention. Full bar of these two types. This, and Andre said yesterday that we should use this built-in to refer to the current instance instead of self. So there is another way to do it, but Andre said that So I cannot see any example close by, it doesn't matter, but you have self, and you have self is like a parameter when you create a function or a method, not a function, but let's say method. Then you have this self that is wired under the hood, and you can use it. But Andre says that this is better, that they changed the language, that this is now the recommended way of doing things. And you can see it's a built-in function. So this add means it's a built-in function. This is the name of it, and this is just like calling the function without parameters. Can be used to refer to this struct type in fields with in files with fields. It is quite common to name the type here, so it can be easily referenced by other declarations in this file. So let's see the example. They create one constant, they call it top level fields, and then they take this built-in, they call it, and then they will get the self, if you will. And here they create a function, they call it init, which has one parameter called value of this type u32, and returns this type. And this type will contain, you can see here what it returns, so anonymous struct tuple, which will contain foo and bar fields set to these values. So basically the same value here, they just assign it directly. Here they multiply by 10 and then assign to the bar. Yeah, this is interesting concept. These things here. Let me see what you guys wrote. Self like pi, right? Yeah. So in Python itself, I know in Java it's this. So depending on the language, it's going to be different. Let's see what Andre says. In code example, you can see they assign proper name instead of self. This is not a language change, but just how people prefer. Aha, it's not a language change. Okay, thank you for explanation. In case of regular struct, you don't need to use this to get name, since it will be inconstant. So you just use that. Yes, so this is a special case because we are now here in the file, on the file level. So we are running this file, executing the file, and then it's not explicitly a struct, but it is the file as a struct. So that's why. Okay. Such files can be instantiated just like any other struct type. A file's root struct type can be referred to within that file using this. Yeah. File and declaration discovery. Zig places importance on the concept of whether any piece of code is semantically analyzed. In essence, whether the compiler looks at it. What code is analyzed is based on what files and declarations are discovered from a certain point. So this is the declaration discovery. File and declaration discovery. So how you discover files and declarations. This process of discovery is based on a simple set of recursive rules. If a call to import is analyzed, the file being imported is analyzed. If a type including a file is analyzed, all comp time using namespace and export declarations within that file, that type, are analyzed. If a type including a file is analyzed and the compilation is for a test and the module the type is within, and the module the type is within for test, for a test and the module, the type is within the root module of the compilation, then all test declarations within it are also analyzed. If a reference to a name declaration, like usage of it, is analyzed, the declaration being referenced is analyzed. Declarations are order independent, so this reference may be above or below the declaration being referenced. Yeah, so we already know this is a fact, or even in another file entirely. That's it. Those rules define how Zig files declarations are discovered. All that remains is to understand where this process starts. Yes. So I haven't touched Zig on my local machine yet. So I'm still working on the here this online editor, Zig -play.dev. So that's why this kind of doesn't not apply to me, but for what I'm doing now, this is not what I can test now. So I would have to first install Zig and play with these things. But definitely this is like when you start coding professionally, with the language you want to have, of course, files and folders. And then this is going to be very important to understand. The answer to that is the root of the, so where it starts. The answer to that is the root of the standard library. Every Zig compilation begins by analyzing the file, this one. So standard library, std, a folder, std.zig. This file contains a comp time declaration, which imports libstd start zig, and that file in turn uses import root. So that's why your file, that's what they explained before. So that's why your main file is loaded because of this. Reference the root module. So the file you provide as your main, yeah, that what they said above, as your main module's root source file is effectively also a root because the standard library will always reference it. It is often desirable to make sure that certain declarations, particularly test or export declarations, are discovered. Based on the above rules, a common strategy for this is to use import within a comp time or test block. So now they provide the example. So this is to make sure that they are discovered. So let's see. They have one comp time block and one test block here. And then let's see what they do. So in the comp time, they just import the API Zig and dump it so that the compiler doesn't complain that it's not used. And let's see what they say about it. So I see what they import, api.zig. This will ensure that the file API Zig is always discovered as long as the file is I cannot see the end. As long as this file is discovered. So as long as this one, they want to say, of course, file is discovered. So as long as this one is discovered, this one also will be discovered. It is useful if API-Z contains important exported declarations. We could also have a file which contains declarations we only want to export depending on a comp time condition. In that case, this is interesting. We can use if statement here. So only if the operating system is Windows, you want to import the Windows API, which makes sense, right? So now I have conditional discovery. Then in the test, this will ensure, so let's see first what they do. The same thing like here, they just import a different file name. This will ensure, but it's, of course, the difference is the main thing is that it's in the test, not in the compile, in the comp time block. This will ensure that the file testzig is always discovered as long as the file is, as long as this file is discovered. If this compilation is a test, okay, it is useful if that's, yeah, the same thing. So they work in the same way. We could also have a file which contains tests we only want to run depending on the comp time condition again, like previously. So the same. And then they create a const built in and they import. So this one is not during the comp time, not during a test, but in a regular runtime, regular compilation, sorry. Special root declarations. Let me see what you guys wrote. Built in here is that file you read before. Thanks, Andre. Special root declarations, because the root module's root source file is always accessible using import root. It is okay, this is a typo, I guess. It is sometimes used by libraries, including the Zig standard library, as a place for the program to expose some global information to that library. Okay. As a place for the program to expose some global information to that library. Okay, the Zig standard library will look for several declarations in this file. Entry point, when building an executable, the most important thing to be looked up is this file, is the program's entry point. Most commonly, this is a function named main, which std_start will call just after performing important initialization work. Alternatively, the presence of a declaration named start. So I was wondering, like, if you can avoid using this one, can you do something in a different way? So that's the alternative. If you have a declaration named start, for instance, pub const start equals, and then this code block will disable the default std_start. It's interesting logic, allowing your root source file to export a low-level entry point as needed. Let's see what they provide here. So they have one function, the main one, standard one, and then they call std_debug print hello world, and then they have this part where they create the start with underscore at the beginning as a prefix to an empty. So they assign the empty code block, right? The void, basically here. I believe this is like a void. It's empty pair of curly braces. And they say if uncommented, this declaration would suppress the usual standard start logic, causing the main declaration above to be ignored. So let's actually give it a try. Let's see what will happen. So if I do this here and I uncomment, let's print first like this because it's commented out. And I have already this std above, so I don't need it 2 times. So this is the regular thing, running the regular main function. And now if I uncomment, so I guess it will just run and not display anything because I don't have any code that I set to run. Okay. What they say is an error warning link, unexpected LLD std error. Cannot find entry symbol start, not setting start address. So maybe this is specific to this runtime because I'm running it online, so I don't control everything. It's a sandbox, so maybe it's that's the reason why this breaks. Let me see what you guys wrote. Lib std start zig. Okay. So let's see what they comment for before this part. std_start imports this file using import root and uses this declaration as the program's user provided entry point. It can return any of the following types: void, e, so this is the union of e type and the void. So this is just the type of the error. They create type for the error, then u8, and it can be union again of this type and u8 for any error set e. Returning a void value from this function will exit with code 0, so it means fine. Returning a u8 value from this function will exit with the given status code, so error code. Returning an error, that maybe that doesn't necessarily have to be. I know that usually when you have exit code that is not 0, it's an error, but maybe they also use it for something else. Returning an error value from this function will print an error return trace and exit with code 1. Okay. Let me see what Andrei wrote. It wants symbol to be exported. Write pub. Let me. Where it is here. So see what you say exactly. Write pub export fn start void instead. Okay. So instead of this one, or should I? Yeah. Okay. That's why. That's why I asked. Because of the underscore. So pub export fn start with underscore, and then it has void as return type. Okay, let's run now. Ah, okay, my bad. Duplicate struct member start. Ah, okay. Let me see what you read. Will default since you need to close program yourself. Aha. Okay, okay. Let me just try to do this. Yeah. Okay, okay. So let's see the next thing here. This was the entry point. Wait. I lost the trace. This is the part that I read. Okay, now if the Z compilation links libc, the main function can optionally be an export function which matches the signature of C main function. So in this case, they have that situation. So function main, but this time they write it with the C main. Yeah, I remember this from C. So I mean, not the Zig type, obviously, but these like argc things. So this also like in Java, you have these args in the main. Okay, so they create function main. They have argc, which is C integer, argv, which is pointer. I keep forgetting how they call this, to a pointer to the multiple something. So constant pointer to multiple items. I think that's the official name. And this is the zero terminated, constant pointer to the zero terminated, I think, array of U8. So I'm still struggling visually understanding if it's a slice or an array. I keep confusing those two in Zig. And the return value is C integer. Then they have const args. They set from these parameters here. They have a specific range that they want to take from the first element up to. Then they take the argc and cast it to integer. So that will be a number that will tell you, like, take the first 2 or 5 or whatever number of arguments. Then they print hello, arg v0 is, and then they print it. Okay. Let me see what Andre wrote. You can use std process exit 0 to close program and avoid. Okay. Thank you. Let's see what else they say. Std start may also use other entry point declarations in certain situations, such as win main or if fi, how you pronounce this, main, refer to the standard library start Zig. Logic for details of these declarations. Standard library options. Let me just see one thing here. Just want to see. So we have this one, and the panic handler is the last topic on this part. And then I will see the targets. Okay. Standard library options. The standard library also looks for a declaration in the root module's root source file, named standard options. If present, this declaration is expected to be struct of type std options. and allows the program to customize some standard library functionality, such as the stdlog implementation. Okay, and then they provide the example. Let's see what they say. The presence of this declaration allows the program to override certain behaviors of the standard library. For a full list of available options, see the documentation for std options. So we are going to override some behaviors. Let's see which behaviors. So they create a constant std options of this std options type, and then they use this tuple, and they have two things here. So dot enable segfault handler. I don't know how to pronounce it, segfault or segfault. Segfault. And log fn. So they set this one to true, right? And then they have a log fn field, which they set to my log fn, which is this function here. So I will go there in a second. I just want to read these comments first. So by default, in safe build modes, the standard library will attach a segfault handler to the program to print a helpful stack trace if a segmentation fault occurs. Then, because it's short for segmentation, I guess it's pronounced seg fault. Here we can disable this, or even, what does it say? Enable it in unsafe build modes. In this case, they are enabling it in the unsafe. I'm guessing correct. So this will enable it, I believe, to anything, any mode. And then let's see the mylog function. So doesn't return anything. It has 4 parameters: level, scope, format, and args. Level has to be of this standard log level type. Scope has to be of the type whatever the function, built-in function type returns from the enum literal field. And format is a constant slice of U8s, and args are any type. So these are your inputs, right? And then the void doesn't output anything, and it just has one line that runs. We could do anything we want here, but actually let's just call the default implementation. Okay, so they take this stdlog, this default log method, they pass these 4 arguments that they receive through these parameters, and that's about it. Okay, then panic handler. Let me see what you guys write. They enable it always if you, so you're speaking about this part. If you want to enable conditionally, you would write enable segfault handler equals. So instead of true, they would say import built-in mode equals. I will just type it here so that people can see, because I'm reading the comment. So I'll just type it as a comment here. So this enable, that part is the same. So this part is, so actually let's copy this entire thing just to have a better look of it. So instead of this, what Andre is saying is that we can do a bit different thing here. So let's import built-in dot mode, if I'm not mistaken. Yes, equals, and then dot debug or something similar. Okay, so this is what Andre says. Thank you, Andre. This is if you want to enable it conditionally. Okay, so then let's move on to the panic handler. Zig standard library looks for a declaration named panic in the root module's root source file. If present, it is expected to be a namespace container type with declarations providing different panic handlers. See STD debug simple panic for a basic implementation of this namespace. Okay, I'm not going to do that now. Just want to have the overview, overriding how the panic handler actually outputs messages, but keeping the formatted safety panics, which are enabled by default, can be easily achieved with STD debug full panic. Okay, then they have a main function. They call this built-in set runtime safety to true. We call it and set it to true. Create a variable x of u8 type 255. Let's overflow this integer, so they increase it by 1. Then they have an overflow. Then they have a const panic, which they then set to whatever the full panic method on this standard debug package returns when you pass the my panic, which comes from where is my panic? Here. Okay, so this function is they pass the reference to a function. So this is the reference to this function my panic, and this panic my panic function receives two parameters, one constant slice of u8 called message, and another parameter called first trace address, which is an optional of u size and has no return for the return value. So they just dump the first trace address, then they print panic with the message injected here, and then they exit the standard process. So they terminate here. Okay, so this is the method that they pass here as a reference. And then they set the panic to, and then they, so this is like a callback or something. I'm not sure what this will cause. So this function will run here immediately, but this is just passed as a reference. So I don't know if it's going to run it immediately. I mean, this panic, guess it's going to be like the event or something. So it's not going to be called immediately. Okay, let me see what you guys wrote. No underscore. This is not a reference to a function. This is a function. Think of it as passing body of a function directly. Aha, okay. Yeah, because in other languages, this is like if you create a function and do this, this is then like a reference. Okay, thank you. And no underscore. Let me see what you referred to. Enable. I'm not sure what you meant by no underscore. Okay, sorry, my mistake. I was typing quickly, and thank you, didn't see it. Okay, so this is from this part. Now I want to go to the targets if I have time. How much? Yeah, I'm almost live in a stream. I just want to cover this one more topic if it's not a huge one, because it is related to compilation. And yeah, it's a small one, so we can go through this one just to kind of like wrap up the compilation part of the docs. Let me see what Andre wrote. Search for STD debug full panic in STD docs. So it's in the docs. Let's see. So I will find it here faster if I scroll where it was. Here, panic handler. So STD debug full panic. Okay, and let me search it here in the other screen. Okay, it's mentioned only here, but I guess this is not this part of the second to see documentation. And then do I have some search here? No. I search it here, what it will find. the same thing. Let me go to here. It brings me to the master. Is there a search here I can use? No. So if I click get started, it will bring me back to the docs where I came from. And if yeah, it's the same like here. No, this is directly to 14.1 and get started. Here we have a different resources. So somewhere here at the bottom was this learn vegan docs part. Let me try to search it like this. So if I do this and I say site zig, it's not that, but site. It finds it only here. Yeah, only on this spot. So I'll try to look for it on some other place. Let me see what you wrote. You can get to them by appending std to your current URL. It's second link on the docs page. This one. Thank you. So here, what they say, a fully featured panic handler namespace, which lowers all panics to calls to panic FN. Safety panics will use formatted printing to provide a meaningful error message. So maybe I'll zoom in a little bit for you guys if you're watching on phones, where I were. Safety panics will use formatted printing to provide a meaningful error message. The signature of panic function should match that of default panic. And then I will take a look into this one as well. So panic function, so this is literally like what we've seen in the docs, how they made one. Values call functions. Okay, these are other functions. So this is what they want to say, and this is the default panic. Dumps a stack trace to standard error, then aborts. Parameters. Okay, source code. Default panic. So the signature is the same. I'll just take a look at the body. So they call this branch hint called the built-in. Then for backends that cannot handle the language features depended on by the default panic handler, we have a simpler panic handler. So then they have these, they test for different backends, right? And then they test, for example, here if it's the stage 2 VASM, or so depending on the processor, and VASM is a virtual, not existing processor, basically based a machine, an assembly that is targeting non-existing processor. Then they have trap here. Then they have a switch built-in OS tag. So if it's freestanding or other, they trap. Then they have, if it's UFI or how you pronounce it, then let me see. So I'm not going to go, because it's huge. So I'm not going to just read all these now, but definitely it's an interesting one to research. I mean, I would like to read also these, but don't want to make this stream too long. Let's go back to here and let me see what you wrote. Sorry. If you open source code doc, you will see what it does. Just a function helper to convert simple panic handler to panic handler. Standard library expects you to provide. Okay. Read full panic, not default panic. A second to see. So this one. Did they open the right one? Yeah. The full panic. So Let's see just quickly what it does. So returns a struct. There is a call constant, panic fn. So this is the constant that you pass the function. Then they have 1, 2, so let's say maybe 30 or so, or 40 functions defined. Sentinel mismatch, unwrap error, out of bounds. So yeah, they're specifying different functions to react on different scenarios. Yeah, this is interesting. Interesting. And let me see just at the end, after it defines all these, what they do. Okay. So these are other things now, not related directly to the full panic. And let's just read the comments. A fully featured panic handler namespace, which lowers what we saw already there. Which lowers all panics to calls to panic function. So it gets a panic and then it delegates it underneath to the panic function that you defined, that they define in this example. Safety panics will use formatted printing to provide a meaningful error. Yeah, this is the same what I explained before. Yeah, so this is what they want to say, that it will just delegate whatever panic occurs to the function that you provide, and this one will deal with it, so in the way you want. Okay. Let me see what you guys wrote. Hello, Jorge. That branch hint called is really interesting. That was where it was. I lost it for a second. So it was a default panic, I believe. Yeah, this one here. Jorge is referring to this one. So he says it's very interesting. It optimizes your code, assuming it won't usually fail. Yeah, remember this when we went through the built-ins, that you have like 4 or 5. It's an enum of 4 or 5 values that you can use. So this one called and 4 others, if I'm not mistaken, maybe 3 or 4 others, which is basically about the probability that this, what you say, like assuming it won't usually fail. So the probability if it's going to fail or not. Yeah, it's cool concept. And let's see what Andre says. So you can provide struct manually with different functions for all panic cases possible. But most of the times you don't care. So I think Andre is now referring to where it is here. So to this return struct, right? So about this. So you can provide struct manually with different functions for all panic cases possible, but most of the times you don't care and want to handle them in the same way. Yeah, I mean, this is if you have very specific problems that you want to address differently. So most of the times you will not need to, but they left you an option. So if you really have something very specific, and if it will either like speed up your debugging or any other benefit that you can have by customizing some panics, then makes sense. And Andre says you can only fail once, so it sure happens rarely. Yeah, now it makes sense. It's also here branch hint, so I was blind. So not only here in the default panic, but here in the regular one, full panic. They have it everywhere for every single function. Here they have, and they're all called, like Andre said, because you cannot panic multiple times at a given moment in time. Let's see what Jorge says. Yes, in panics is more obvious, but in case of so now Jorge is referring to these ones. branch hint. In the case of log error, it sneakily does that for you. Okay, and let's do this last topic just to read about the targets. So text. Target refers to the computer that will be used to run an executable. It is composed of the CPU architecture, the set of enabled CPU features, operating system, minimum and maximum operating system version, ABI and ABA version. Zig is a general purpose programming language, which means that it is designed to generate optimal code for a large set of targets. The command Zig targets provides information about all of the targets the compiler is aware of. When no target option is provided, the compiler, the default choice is to target the host computer, meaning that the resulting executable will be unsuitable for copying to a different computer, which makes sense. In order to copy an executable to another computer, the compiler needs to know about the target requirements via the target option. The Zig standard library, import std, has cross-platform abstractions, making the same source code viable on many targets. Some code is more portable than other code. Yeah, depending what you want, which features. Of course, in general, Zig code is extremely portable compared to other programming languages. Each platform requires its own implementations to make Zig's cross-platform abstractions work. These implementations are at various degrees of completion. Each tagged release of the compiler comes with release notes that provide the full support table for each target. Yeah, that's useful. Yeah, they cover the main architectures, and then maybe if someone needs very specific thing, they can do these things on their own. If they try to, I don't know, so if you want to code some drone or something that doesn't have OS, so then of course you would have to make sure that you do all these low-level things that Zig will then just use as a target for your specific hardware, because it cannot know what is there. Yeah, and I would like, for example, for some like future moment in time when I have time, what would be interesting to play with is to create something for like a target for a specific old school computer like Commodore 64, for example. That was my first computer that I got as a child. So that would be a fun project to work on, to make a target for Zig, so that I then can just like write a Zig code and then target Commodore 64. That would be interesting, especially because it's so low in memory. I mean, just for fun, not to actually do something serious on C64, but just for fun. To see Hello World running on Commodore written in Zig. That would be amazing to see. Let me see what you guys wrote. Andrei says, also notice since it will crash. Can hear about where it is here. Since it will crash after panic functions marked as no return. Since it will crash after panic functions marked as no return. Okay, yeah. So it will not return from that function because it will crash. Makes sense. Zig targets gives you 24,944 lines. Yeah, so that's interesting. That's interesting. Okay, so I think I will stop here for today. And for tomorrow, let me see what is the plan. I went through this compile part, source encoding, WebAssembly. So this is something that I'm personally very interested into, but I just want to go first through the most generic parts of the docs. So I stopped here basically. So build mode, single threaded builds, illegal behavior. So maybe I'll do illegal behavior next time, or memory. Memory variables I've done today. Zig build system. So I will do build part of it when I install Zig finally on my computer. Yeah, so it's not that much of that, like we don't have that much of topics left. Only few of them, and only 7 days more till the end of this coding challenge. So I guess I'm going to do memory tomorrow. Let me see if it's a big one. So it's up to compile variables. Let's see. Yeah, okay. So yeah, this can be for sure handled in 1 hour and less than 1 hour probably. So then I will see after the memory what I will do. Let me see what you guys wrote. Jorge says next project is a Doom port for your fridge instead of a tic-tac-toe. Yeah. So at the beginning, I think you weren't here, Jorge. So at the beginning, I said, I know that I promised I'm not going to touch tic-tac-toe anymore, but because Robert made an improvement to the code, so I would love to go through the code once he's here. So I don't know when. So today he's not here at the moment, so I will not do it today. But I will definitely do one more video about tic-tac-toe and see what Robert, how Robert improved code in a way that is implementing more things that show some specific parts of Zig that are interesting for interesting for learning. And I was thinking about the next thing to do something like 4 in line, so that I can play with things like saving states, because it's a bit larger than tic-tac-toe. So you have, by default, I think the main version of the game is like 10 by 8 or something like that. So 80 fields or maybe 100 by default, but I will make it dynamic that you can select the width and height of the board. And the interesting part would be also like this gravity that pulls your piece down, so you can also always have only one place you can put your piece in every column. And also to practice this file handling part, where I will maybe start one game and then play 3 turns and then save the state to a file, so that I can then start another one and then save that one and then maybe load the first one and continue. So these kind of things, so that I play a bit with files and these new things that I've went through from the last time I did tic-tac-toe. So I think this is going to be the next small project instead of tic-tac-toe. And then after that, I will see, I don't know. So I personally love these kind of things like WebAssembly. So I will definitely look into it, how it looks like here. And this is, I believe, more interesting to do live to most of the people than what I just said like 10 minutes ago, doing something like a code in Zig that I will compile then to run in Commodore 64, because then I have to play with these targets, and I don't even know how what Zig expects to have there. So it would be much more complicated for me, and I don't think it's so interesting for the most of the people. Like the target itself, Commodore 64, not the process. Probably the process is more interesting because if you're creating a target for compilation. But I think this is a bit more advanced at this moment for me. Because I'm just 23 days into Zig. So I want to use, I want to do the easier stuff first to practice. So maybe I will do after this 4 in line something with WebAssembly. Maybe. And I will definitely go through this maybe the last day or something like that before. So I will try to go to more, let's say, general things that you can use Zig for that is not target specific. And this is already like a target specific. So you're targeting a specific WebAssembly, and the WebAssembly has its own features and things, what is it's meant to do. And it's kind of like a container, which is the word on its world on its own. So that's why I'll probably do so that's why, for example, the C as well. So it's a very specific use case. So who wants to do something like interoperability with C? Of course, this is interesting to that person, but it's not something that everyone will do. And I will try to first finish the things that most people would like to play with in these 30 days. And then after that, I will do something of my preference and what I personally like to do, so that it's more applicable to something specific. Let me see what you wrote, sorry. Yeah, that and an optimized version might be cool. You could use the raylib bindings. Who mentioned? Someone mentioned, I think Andre mentioned raylib yesterday when I spoke about that. I don't know how the gaming community, how much they are using Zig at this moment. And because of the things that I've seen so far, I already can sense that Zig can be very, very useful and interesting for the gaming community, the gaming developers. So that's why I think Andre mentioned this. Maybe you, sorry if I forgot. But someone mentioned raylib yesterday. You could use raylib bindings just to practice using libraries. Yeah, but definitely check them. So I will write here just to have it here, not to forget. To research into it. Then, so to practice using libraries, the build system, and Wasm. Okay, now that was me. Sorry, sorry, Jorge. Yeah, I mean, you like, there are 3 of you guys that are most active here, and I still confuse. So it's not like I have millions of people watching this, and it's very hard to memorize. But yeah, sorry for that. It was you. So did you do something fun with this? What did you use? Raylib Zig. This is C++. Yeah, I didn't even see here that they are speaking about C++. If you go to raylib, then you'll have to go to linking C. Okay. I see even a few videos here about raylib and Zig. Snake game in Zig with raylib. This would be interesting to watch. Yeah, thanks for the suggestion. Definitely worth exploring. Yeah, so definitely things like this I will do after these 30 days. I'll see which I will do first, but definitely they are interesting. Okay, I think I will wrap it here for today. So thanks everyone. Thank you, Andre. Thank you, Jorge, for being here. Thanks, Dev. I will continue tomorrow with the regular day 24. If Robert will be here tomorrow, I will see with him if he is available, so that I can do another special edition of streaming if he's present, so that we can go through his code that he created for the improvement of tic-tac-toe. So that's the plan for tomorrow. Thanks once again, guys, and have a nice night. Or I believe for Jorge it's not night, so it's in Guatemala, right? So it is there, I believe it's 7 hours difference. Here it's 11, so it's, yeah, I believe it's 4 p.m. or something where you're at. So for you then, have a nice afternoon, and here in Europe, have a nice evening. 3 p.m. Yeah, 3 p.m. Yeah, so 8 hours difference from where I'm at in Serbia, Europe. Thank you guys, and see you tomorrow. Bye bye. And I forgot to click here. Yeah, see you. Bye bye.